Okay, we're back. Thank you everybody that participated in that picture. Your skin is worth money someplace. We've got Rick here from Moto Communications. He's going to be talking about graphing OpenSIPS stats with InfluxDB and Grafana. Take it away.
Good. Hi all. As you can see in the sheet, I told you I'm going to be talking about the OpenSIPS statistics and making them good. So let's go to the next sheet. Who am I? I am Rick Roos. We are based.
No.
Can you hear me in the back?
It's move it to the right side. You need to move that to the right side of your shirt. No, take it off that side, move it to the right side of your shirt. I feel like I'm at prom.
Okay, it's better. The things here. Hello, test, 1, 2. Can you hear me in the back? Like this?
I mean, it works. It's just that it's a bit far off.
It's a bit far off. Okay, now it's a little bit better like that. Okay, good. Oh, feedback. We don't need that. This is good? Okay. So I'm Rick Roos from Moto Communications. I'm a voice engineer. We have over 130 OpenSIPS machines in production doing lots of different things, some very high volume and very low volume OpenSIPS machines. It's also my first time speaking on an event like this, so I hope everything goes well. I will be doing a live demo. That's what's all in the presentation. We are going to set up InfluxDB and Grafana. InfluxDB being the storage engine we are going to use in Grafana to present it all nicely. I'm going to show you how to get the OpenSIPS statistics into InfluxDB, as InfluxDB is the storage engine. Then we are going to create a dashboard inside Grafana, so we have to attach Grafana to InfluxDB. And we are trying to get these stats in action and see how they perform live. So on the right side of this sheet, you can see the output of the first command, OpenSIPS ctl5 forget statistics all. Just an enormous list of statistics, and it's not really readable, and every time you refresh the command, it gives new output. It's not really user-friendly to read, for example, but there's lots of different interesting information in this list. So I wanted to do something with it. And the solution for this was, for me, in InfluxDB and Grafana. I tried several solutions, but this one was so easy to work with, so I hope you guys are going to use it as well. What we are using is the InfluxDB time series database. You can just throw values at it with timestamps, and it creates you, it's schemaless, so it creates a schema for you. Only thing we have to do is create a database. And we are going to use Grafana to get all the data out of InfluxDB and present it in a very nice way. So this is one of the things we are going to try to create. So it's really good, it's really simple. So I guess we switch over to the live demo. Is it going on there? Nope. I'm going to kill this. Good. Okay, so what do we have? This is a SIPI already spamming. We have an OpenSIPS machine, and we have a machine on which we are going to install our products. As you can see, I've already downloaded InfluxDB and Grafana. So we are going to start by installing InfluxDB. Let's see if all goes well. Well, that one easy. Is it already running? Let's check for sure. InfluxDB start. Process is started. Great. Let's see. Now we have an interface for InfluxDB. What do we need to do in InfluxDB? It's two things. We have to add another listener to receive all the messages we are going to put in. We are going to create an UDP listener inside InfluxDB. It's a very small piece of configuration. We're going to skip over to the UDP part. Delete all this. Put in our own, which is this. So, I didn't paste it. Good. Why not? insert, right click. This is good. As you can see, we have a bind address of 8125, and the database is OpenSIPS. So everything coming into that port is put into the OpenSIPS database. Now, before we do anything, we have to create this database. Or wait, and restart, obviously. Okay, that's done. Should be listening on the port. 8125, great. So now we refresh this page. We have no database. Oh, we already do have an OpenSIPS database. We created it by a thing. We have no measurements. And we already have measurements. Why is that? It still has some data from my last run, I guess. What are we going to do? Drop the database. Start over. Success. Now it should be gone. It's gone. Create it again. Database OpenSIPS. Show measurements. Success. No results to display. Very good. Next step is to install Grafana. Grafana hardly needs any configuration. We can all do it in the interface. So we go over to the Grafana interface, which is living at port 3000. Errors were occurred because we missed some dependencies, or we can easily fix those. So I already have an OpenSIPS set up because you've probably all seen the OpenSIPS configuration time and time again, so I wanted to skip on that. Grafana starting Grafana. We have an interface. What we need to do is add data source. I already remembered all my things, so I don't want to do that. Delete. Try again. No data source. We are going to add a data source, which is of the type InfluxDB. We call it OpenSIPS. The URL is our local address. You can see 192.168.23.162 or 8086. Database OpenSIPS. Admin. It's a database we just created. Add a node error. Internal server error, obviously. Why is that? Let's have a look. Maybe it's HTTP, save and test. Data source is working, very good. So we now have an empty database, and now we want to get some data into it. So how are we going to do that? I've written a script which uses the MyDatagram interface from OpenSIPS. So the only thing you have to do in OpenSIPS is configure the datagram module, which is here. It's listening on port 8080. You can all read it, right? Yeah, it's very good. Good. The script is written in Ruby because there exists already a module inside Ruby which can talk directly to the MyDatagram module, so I just used that. Let's see, we're going to start with statistics scripts. Later on, I'll show you where to get the scripts, and it's all very easy to configure. The only thing you need to do is add your IP address here. This is for the datagram connector, so this needs to connect to OpenSIPS. OpenSIPS is living at 161, and here we connect to the InfluxDB, which is living at 162, port 8125. And as OpenSIPS is already running, yes it is, we can start the script in a screen, otherwise I have nothing to do. Ruby statistics.rb, and it's running. As you can see, as we saw just now, measurements were empty, now they should be filled. These values probably come very, you probably know them as they are all the output from the OpenSIPS CTL get statistics script. It automatically formatted the database in this way so I can easily use it in Grafana. So we are ready to create our first graph. We are going to create a new dashboard. We're going to add the graph panel. In this graph panel, we want to use the OpenSIPS as source. And now here in select measurement, we are going to build queries to create all these graphs. So for example, what's interesting to see is mostly your memory. You want to do how much memory your OpenSIPS is using, and where it's going and what's happening to your memory. So we pick shmem, and then down here we can drill down in all the other values that's available in the OpenSIPS CTL command. I mostly use the real used size. Give it a good name. As you can see, there's already a graph popping up. Now we have on the left, our axes are incorrect, so we can change the unit to make it use, I think it's in bits. I mostly use bits. Now what's nice to do is add another query, which also shows your free memory, so you get a complete range of memory that's in use. It's the free size, so now we've got 2 lines. As you can see, my OpenSIPS is only using about 3 MB of memory at the moment. Let's see if we can fill those lines up. That's our first graph, so you can see how easy it is and how fast to set up. Let's give it a nice name as well. This is our shmem. We can add another row. We can add some more statistics. Let's see what else would be interesting to see. For example, you have the user log module. You can see how many users there are registered. You can graph it now with Grafana with the same statistics. So we just use the registered users. And as I've just shown, I've already got the SIPI running. The SIPI is just sending out registers at a steady rate at the moment, and we can see what happens to this line over time. It should fill up slowly. Let me turn on this. We are going to check the last 5 minutes. But we are going to refresh this every 5 seconds. So as you can see, it's spiking, and if I increase my SIPI to send some more registers, we should see this line gradually going up. It's pretty quick. It's very responsive. Oh, I shouldn't have clicked that. It's moved out. Last 5 minutes. Back to dashboard. That's looking like something already. Forgot to name this one. Registered users. Let's give it a nice name. Just use something. The line is steadily climbing, stabilizing at this point. Let's put SIPI up some more. See what happens. Memory is still going very stable, so the registers don't seem to do anything to the memory as of yet. But we will change that. Let's see what other information is interesting to add. What I like to do is have the transaction module list it's what's called the in-use transactions, so you can see how many transactions are active within OpenSIPS transactions. Always give nice names. Transactions is currently flatlining, and as you can see, it's also going negative. That's also a very easy thing to fix. On the left, no, on the axis, we set the y minimum to 0. So that brings the line to the bottom, because you can never have negative registers, so we never need to go below 0. So, 3 graphs already. Let's see, which do I have here? This is an example dashboard I've already made. Dialogues, obviously. We put this next to the transactions. So we're going to add another panel on this row. Which uses the dialog from the statistics info. And it's going to show us the active dialogues We could also add the early dialogues, but in my experience, they hardly move. Sometimes you see them moving, but they are so quick, the early dialogues, that it hardly shows up in the stats. We can try for now, see what it does. Early dialogues, good. And as this axis also will never go below 0, we do this. We put the I in, and that drops the line down. All very easy. So now we have no transactions running. Let's see if we can get some transactions running on this. So I just start another SIPI, start calls. And we are going at 10 per second. Let's put it down a little bit. Now we already see the transactions increasing. Dialogues isn't because the calls aren't answered. It's just sending in invites and doing for waits to get stats moving. Looking very good. Well, we have most of the statistics. Now, as you can see, we now have core dialog, net, PK, net, for SHMM, SLT, and URI, and usable log. We can add one more because I've written a different script. It's based on the rate limiter. Let's keep this in green, it's much nicer, obviously. The rate limiter, we can also see now a bump in the SHMM happening, so probably if we increase our SIPI, this line, our memory should start moving. Very good. Let's continue a bit more with this P statistics before I introduce the rate limiter. I could also add an answer, so we can get some dialogues running, which will break. So the dialogues will keep standing, that's good. Let's see, we need this one, accept. Okay, now the calls will be accepted, at least 32 until PJ Sua stops accepting new calls. So we should see this dialogue. Oh, I haven't named this correctly. Let's fix that. And we can also already see it jumping up. As you can see, the early dialogue is still flatlining as the state is hardly ever hit. It's such a short state. It only is in the statistics for a very second. And as I told, get statistics every 5 seconds. It hardly ever moves. As you can see, the transactions is moving nicely. Memory is also giving some bumps. Still nothing too serious. OpenSIPS is handling this easy, as it should be. So, this one crashed. Let's get some more calls in there. Just run it a few times, and we should have some dialogues and active, which get automatically killed after 5 minutes. Yep, dialogues going up. We are already at 95 and climbing, so that's nice. Memory, we're all steadily going. So let's see if we can introduce a rate limiter module to it. It's not a script, it's very much alike. It's on this machine, detached from the screen. So the rate limiter module is already configured in my OpenSIPS script. I only have to configure the script to this one, that's rate limit.rb, yes, that's the one. We do the same, configure, to talk to the OpenSIPS and my datagram interface, 162.161 is, and talk to our InfluxDB, which is moving at 162. Open the screen and start the script. Ruby rate limit.rb. This also gives some output of the pipes available. So we have 2 pipes at the moment. One coming from SIPI and one for general invites. So all invites are landing in one pipe. This is also happening for the register, which you can also see a register pipe in here. Because we currently have a SIPI running spamming registers and we have a SIPI running spamming invites. So let's see what's happening to the stats. As I've shown you before in this, we now have these measurements, and if we now refresh, we also have RL, which stands for the rate limiter. So this shows that InfluxDB dynamically generates the schema, and it's just generally very easy to use. So we are going to add another row to include our rate limiting. kernel graph. Use OpenSIPS. And what are we going to include? We are interested in the rate limit and below ID. We can see all the pipes appearing. So for now we are interested in how many registers are coming in. So this is the graph already drawn for the rate limiting since I started the script, so there's already some data in it. This is registers. The access is fine. And we are also going to show the invites in this same graph. But what we are going to do with it, as the rate of these values can differ greatly, mostly less, depends, but mostly these values are very different from each other. So we don't want them to use the same axis on the left. We want them to use a different axis. So we are going to put in a specific override. Okay, I didn't name it, but it's important that you name all your queries before you are going to add exclusions to it. So we name this one the invites. And for display, we add a specific override. Here you see the queries now popping up. So I use the invite one. And what are we going to do with it? So we are going to use y-axis 2. So now we have two y-axes, one on the right, one on the left. Registers using the left one, invites using the right one. So now we can massively increase our invites weights. Let's go up to 80. See what happens to the rate limiting graph we just created. As you can see, it's already climbing. Seems to stabilize at this point. It's very quick, very interactive. It's very nice to work with. Also, we see memory going down. Let's push it some harder. We still have these dialogues from the PGSUA accept script, which are still standing. We could also print some legit calls and end them. Maybe that's nice to do. What do we have to do then? We have to kill our invite CP. Start the accept script again. Still incoming. So let's wait until all the invites are done spamming. Okay, seems to be very idle now. We have 0 active calls. This is the wrong machine. We need this one. And here we have a PGSUA initiator script from which we can start multiple calls. We are going to create 20 calls, and we're going to do it to a random string back by OpenSIPS machine. 93. 93.161. There we go. 30 calls. They should be incoming. Yes, we have confirmed states. So now our dialogues will be increasing a little bit. We zoom in on this part, see what happens. Hang up some calls, just a couple. See what happens to the stats. Still auto refreshing in this way? No, it isn't. Let's just keep using this. Now we see the line dropping a little bit. We went from 176, 178, 179. Very responsive. We have some more calls, and we see it dropping again. We can also see our lines crossing here in memory. Mostly at this point, I'll start to investigate why my memory is so high. Increase the memory, or see if it's a leak or anything else. But as you can see, OpenSIPS is managing very nicely. So yeah, that's how you create a dashboard in Grafana. It's all very easy, and I hope you guys feel interested now to use this as well. We can have a look at this dashboard if there's anything else in it. I'm also graphing in this dashboard. It's the same statistics, just the scripts running twice in the background. So these graphs should be very much alike. Here we can see the relative user transactions. The only one I didn't create was the PK memory usage. But as I heard in the presentations before, there's now some new statistics coming for what every module is doing. So I'm very interested to see how that will perform in Grafana. It will be very nice because now you can't really see what each process is doing or what each process is. You can see some minor bumps in here, which you have no clue which process is what, as opposed to numbers. Let's head back to the presentation. So, what have we actually done now in the previous 20 minutes? We've installed InfluxDB. We've created a database inside of it. We've installed Grafana. We coupled Grafana into InfluxDB. We did a little bit of changing of the configuration in InfluxDB. Only thing we had to do was configure UDP listener. We pushed data from OpenSIPS. We pushed data from the get statistics. And we pushed the rate limiting data. We've created some basic dashboards from which you can start toying yourself. It's also very much possible to create counters or whatever you want. For example, now we've created a graph of the dialog counter. I can show you in a bit. You can also easily create that as a single value. So you can create exactly the dashboard that you like from the statistics. And obviously, it looks very good. I hope you agree. So I can show you how to create a It's not very difficult. So instead of dialogues, we're going to delete this one, and we want to use it as a value. Oh, this is the one dashboard, that's okay. It's not saved anyway. Always save before you quit. Very important. So delete this one, yes. And we are going to add panel. And we are going to add a single stat. This single stat, we have to do a little bit of manipulation on it before it does what we want. So we are going to use this, the active dialogues. Active dialogues. And we are going to override the time range. Why is that? Because otherwise it generates a mean over the time. So in this, it would create a mean over the last 5 minutes. We want that. We want to show the actual value. So how do I name this again? I just have to put something in. 10 seconds. Is this now active? It should show me if it's active. I'm not convinced yet. Oh, here, it is active because it shows up here. We hide the info. Oh, it would be handy to have the graph next to it, so let's recreate that so we can see it's showing the actual value. OpenSIPS. Dialog. The ID is the active dialogues. We can see the timeout now hitting from the calls we started earlier, which was still stuck in OpenSIPS. So this should be at 44, and if we start to increase it again, which we can do by starting our CP instead of the PG Sura, we hang up some more calls. Start calls. There we go. This one is still accepting, so it matters. Oh, great. Just accept my calls. Create some dialogues, please. There we go. Line is going up again. Value is nicely increasing with this. This is 96. Looking great. If I didn't add the, if I skipped the time range, I can show you. It shows a completely different value. It shows 131, which is the mean over this complete graph. So that's not what you want. But if you play around with it a lot, you easily find out it's very easy to add exceptions, to draw your graphs. It's a very strong tool. So back to the presentation. How can you set this up yourself? Well, I've made the scripts available. Next sheet. Not working. sync screen. There it is. Here we go. It's over on GitHub. So there you can get the scripts, look over them yourselves. The first version of the scripts that I've written were actually based on just scraping all the info of the OpenSIPS CTL FIFO command. But if you use that, you get lots of hanging processes from the FIFO CTL, from the FIFO command. So the new version is written on the MI datagram version, which is overall performs much better. InfluxDB you can get from the second link, and Grafana, which is the interface to draw all the nice statistics, you can get on the third interface. So I really suggest you all just try to use this. Only thing you have to edit in your current OpenSIPS, if you're not already using it, is to add the MI datagram listener. That's all you need. And obviously get these scripts running, but all the instructions are up on GitHub. So I invite you all to take a look. Are there any questions about this? Do you want to see some graphs created? Let's have a look at the dashboard again. Any questions about this? Was it clear? Are you convinced to use this product?
Yeah.
No questions?
How does it compare with Cacti?
Well, I haven't quite used Cacti myself a lot, but in my experience, it's very difficult to get the graphs working correctly. And in this, it's just point and click, and you have graphs. It's so easy to create. It's also very easy to do maintenance on in the database. You can just drop one measurement if the wrong data gets in there. Or it's overall very easy to use. And yeah, we've also worked with the RD tool. If you want to add something to RD tool, I don't know if you guys use it. It's just terrible. It's unusable. You have to do all kinds of tricks to keep your data intact, your historical data. It's quite difficult to use. With this, Cacti is also, you can also use it for alerting. I haven't used this for alerting. It's probably possible. You can add all kinds of triggers on it. But yeah, but that's what we still use Cacti for alerting. So, any other questions? And I thank you all for your attention, and I hope
Are you sure you have no questions? Going?